So I've got my big motor here and my little tiny Nano. This motor, you know, more than 35 amps continuous. This Nano can do 35 amps continuous, 70 peak. So it's a pretty good match for this big motor. This is the first time I'd have to clamp down the drive because like the cables are so fat, it's pulling it off the table here. Anyways, I'm having a problem with the indication. I'm trying to jog the motor, okay, and I got some red blinky lights. This is an error for the amp status or the drive status, so the blinking red is a fault. I got some sort of fault, and I'll use CME to figure out what that is. And I've got the network status LED. It's blinking green, which means pre-operational, and there's a fault indicator. It's green, green, red, red. Probably because I don't have my CANopen network attached with the Copley USB to CAN adapter. So we'll do that next. But first, I'm going to hook up with the serial port USB to RJ11 adapter from Copley just to see what's going on. And then I'll check out the CAN network. It's very important to have a terminator at the last node and the terminator installed at the master. And this is, of course, the network adapter kit, which goes from the 9-pin to the RJ45. And this is 9-pin D-sub with USB for the computer on the other end. So we have CME up and running, connected, and I'm just going to look at the control panel. There, I got a command input fault. You can look at the error log and see there's a latched fault, and network status, bus off, guard error, warning limit reached, transmit error passive, warning limit. There's a bunch of problems here. I can't just clear the fault. Somebody's done something to my drive so that I can't clear the fault. So I'm going to look at the CAN configuration here, but you can see I got node address 2 pre-operational, and on the basic setup you can see for CANopen master I'm in the right mode, right? So the drive is configured for CAN in the basic setup, and you can see, well, a command input fault, drive's disabled, software is disabled because master can't enable it. I'm going to try to get rid of this fault first. So we'll take a look at the CAN configuration, and we see use limit switch, and so it's reading the switch value. The switch is right down here, and it can be switched from 0 to 1, or you can program a value. If you have a switch to 1 and a program to 1, that's a 2. Okay, and of course, the address does not take effect until you power up or reset the drive. So you can toggle the switch. It'll tell you what the code is, but you got to save and reset to get that configuration to take effect, to change the node address here. And of course, you're pre-operational because there's no EtherCAT master connected to the thing, and you can't move through the state machine without the EtherCAT master. CME is not an EtherCAT master. But you'll notice here the node guard and lifetime factor are being configured. Now, normally we just configure these over the RAM, but somebody's managed to configure it and save it to flash. So maybe the master connected, like CMO or CML, set the node guarding 200 milliseconds times a lifetime factor of 3, 600 milliseconds later, I get a command input fault. And of course, we can look at the parameter dictionary and see the guard times. These are in the ASCII and CANopen objects, node guard time, node guard lifetime factor, and then there's a heartbeat stuff. But this is 10D over ASCII and 10E. I just set those in RAM and flash just to show that if I save them to flash, hitting the save flash button, having been in RAM, it gets saved to flash, and it gets saved to a CCX file, and it's used to configure all your drives in production. And so you can clear it. This clears the flash too. I'm going to save and reset. I'm reconnecting over the serial port. And now you can see I no longer have a command input fault. I still have the network error because I don't have anything connected to this drive. And if we look at the error codes, bus off, transmit error passive, and warning limit reached. So a warning, no big deal. You know, just connect the master and send some messages. Warnings go away, and it's not connected to a network. So I'm going to test the CAN connection here. So we'll plug in the terminators and we'll connect the network adapter and the USB adapter, and we'll go to Tools, Communication Wizard, and we'll hook up the network. Oh, no devices were found. Wonderful. Okay, so let's try that again. Oh, I gotta plug it in. So taking the CAN, plugging it in, link, link, link. The CANopen drivers for the Copley are already installed on the computer, so it should find the, if you had a Kvaser, you'd have to make sure you have the Kvaser drivers installed. But for CAN, yeah, so on the operating system, the drivers are installed because we installed them. You don't get them installed by loading CME. You got to go get the drivers and install them. They're on the Copley webpage. I'll show you that in a minute. But Copley, it found a Copley, 1 megabit. I got a valid node address. It should look out. It scans a bunch of numbers and it finds node 2 and it connects. And you can see on our CAN configuration, it's no longer configured for heartbeat and lifetime factor because I cleared the flash and it didn't load to RAM, and then I didn't get the command input fault. So I'm making some progress on trying to be able to enable my drive. If you're going to use CME to monitor while the master is connected, you use the serial port. If you want to test the CAN network to make sure you got messages coming and going, you can do CME for that. And you can see that there's no more blinking red light here. So the warning limit reached, the green, green, red has cleared. It says the network's okay. So you've kind of proven that the network is good there. The CANopen master cannot enable the drive if the drive is in a disabled mode. It needs to be in a network mode. And if I had ASCII, I could show you get 0x24 from RAM. 0 is disabled mode. 31 is the network mode. There's other modes of operation, but if you're using a master, you'll be in the network mode, 31. So you could check the 0x24 to make sure it's 31 before you hand it over to the software engineer, or you tell them, go to the control panel and press the enable button. That puts the drive in a CAN mode. This is a CAN drive, Nano CAN standard drive. And so now that we're in a CAN mode, the software engineer can come in and use CMO or CML or some CANopen master to enable and run the drive. So it's the only reason it's not enabled is it's not because of the hardware, active high, that's high, and it's not because of a fault like motor temperature sensor, and it's not because of the stow. I got the stow jumper plugged in there, so torque off is bypassed. And the only thing preventing us from enabling is the master is not connected and it's not enabling the drive. CME is not an EtherCAT or CANopen master, so it cannot enable the drive. We can change the mode of operation to program position, jog the motor, so that we can, set up and tune and phase and all that. But that's just for a test. Don't leave it in this mode. Don't save that mode to flash. Otherwise, your CANopen master can't connect to it. Uncheck that box. Make sure it's in CAN mode. Make sure it's not disabled. Make sure it's enabled. Let's take a quick peek at some of the details here. So we've got on the Copley webpage, under Nano, you've got your data sheets for your EtherCAT and CANopen. And then there's reference board designs for the development board. That's the big board I'm using here, or the little easy board. And we want to see what the blink code is all about so we can look at the data sheet. So EtherCAT is COE, CANopen over EtherCAT, a little bit different perhaps than CANopen, but they're both based on the DS402 protocol for motion control, so very similar. And we can see the location of the LEDs. CAN bus communications. And here's the blinking code, green, 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 blinking pre-op. When it's in operational, it'll be solid. When it's stopped, it'll be blinking at a slightly different rate. If there's a warning limit reached, you get green, green, red, green, green, red. Or if you have a control event, you get red, 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 or sync error, red, red, red. So bus off is a solid red. So the blinking codes are in the data sheet, but they're also defined by the CiA Canon automation, the DR 303-3 indicator specification. So it talks about the blinking codes, and these documents are available to people that are members, of course, or maybe they'll share this one because it's the blinking code, but single green, double green, and you can mix the red and the green together, have a bicolor LED as long as you get the codes right. Some are mandatory, some are optional, so you can look at the definition of the blinking codes. And the most common one is the green, green, red, pre-operational, and warning limit reach, because nobody hooked up the master, right? So a slave all by itself gets lonely, then starts blinking red. There's also a conformance test tool. So if you look under the CiA, it talks about this Coti drivers. And there's a company that we work with, TKE, that they use a Kvaser CANopen stack. So there's some Kvaser drivers that allow this software from TKE to be run. But it looks like they can go through all the CANopen compliance testing. And I assume LED and status. Link. All right. Well, okay. So we may have to ask them, can they help us check the LEDs too? So that may be separate. But at least we can go through different modes of operation, change the state machine, go from pre-op to op, safe, op, or not enabled, and we can send the NMT messages, and then we can introduce node guard errors and check the blinky lights. I don't know if these guys have drivers yet for the Copley CAN adapter, but I think if we ask them to do that, they would do that with a Copley too. But for now, use the Kvaser to test the CAN LED blinking. But as you can see, with the CAN connected, if you're running CMO or CML C++ source code, that would turn into a solid green light. And then, of course, you'd use CME over the serial port to monitor while your master is sending commands over the network. And for the Copley software, under support, under software general resources, we got CMO, and that's Visual Studio's VB.NET examples in there for enabling and disabling. It's just a wrapper. CMO is a wrapper around CML, the C++ source code for Linux. And that would be some licensed software here, the Copley Motion Library for Linux or Windows, C++. It's the source code, so it can do everything and more. And we can read the source code to determine, what goes on the CANopen layer. It's mostly high-level stuff where we just make moves, enable, disable the drive. But if we dig into the source code, you can see all the CAN messages and see how the DS402 is run in accordance to the manual. And so here's the manual, CANopen Programmer's Manual. And this has everything you need to know about the default PDO mappings when you turn the power on. The CANopen drive comes up. This is also the EtherCAT guide, but on power up or reset, these are the default mappings. And you've got your basic control word, which we send to the drive, so the drive receives, and then the transmit. So PDOs are already mapped. So if the master uses the default PDO mappings, you can change